Hello and welcome to this video presentation. In this video, I would like to present to you how to use our concrete mix design advanced template, wherein we can work both for the normal strength or the high strength concrete. Of course, reference to ACI 211.1 and ACI 211.4R. So I have two new features here comparing to our beginner template. In this template, the advanced template, we can work automatically from normal strength, let's say 30 MPa in this example. So you will notice that the title here becomes normal strength as per ACI 211.1, and the selection of aggregates is for the normal strength concrete. If we type in greater than 40 MPa, so automatically it switched to high strength parameters, and now you notice that the 37.5 mm is missing. That is because for high strength concrete, ACI suggests that we may use up to 1 inch nominal size of aggregate or the 25 mm. So the other feature of this template is that we can choose from this drop-down list. Of course, reference or depending on your concrete application, let's say the 0.45 power, the coarseness and workability factor, both working for the pavement concrete purpose. Maybe you want to try tarantula code or the pumpability, self-consolidating or self-compacting concrete combined grading, or maybe you just want to check the fine aggregate limits or the coarse aggregate limits. So in these two graphs you can check side by side, you can study. So that is the main feature of this advanced template. So moving on to this example, let's say we are required to provide concrete mix design with specified strength of 45 MPa at 28 days, cement type type 1 or OPC, nominal maximum size of aggregate is 19 mm, minimum cement content 370 kg per cubic meter, maximum water cement ratio 0.45 with a slump of 150 plus or minus 25. So let's type in 45 MPa, OPC, aggregates 19 mm. So we are now in high strength concrete, slump 150, and let's keep the standard deviation empty since this is new, so we don't have to worry. But if you have standard deviation, you can always write it down here just to show you how it functions. So 370 is our minimum cement content with 0.45 water cement ratio as a maximum value. So if you can notice here, our required average strength is automatically being calculated and provided as the figure 54.5 MPa or 7,905 psi. So in this situation, or in this case, we may refer to the ACI table for high strength concrete, this table. So we are asked to produce 54.5 MPa. So let us try to use the 55 megapascal or 7,977 psi, or you can say 8,000 psi. So in this table for the high strength concrete, 8,000 psi at 28 days with 3/4 or 19 mm aggregates. The water cement ratio is 0.4 as suggested by ACI. This is with the high range water reducing admixture or the super plasticizer. So 0.4. So let's write it down 0.4 here. And of course, again, as per ACI, we should reduce 0.02 to protect us from low strength knowing that there is a potential addition of water at site due to probably the loss of slump due to weather condition like during summer. So ACI suggests to reduce 0.02 of water cement ratio. So from 0.4, let us use 0.38. And for the water content, as suggested by ACI for high strength concrete, 138 kg of water. But due to the fact that we are using, or I am using natural sand and crushed sand with the combined voids, which is very high, so we had to increase to 149 in this example. So to cover that, I increase actually the cement from the 370, let's say 370, it will not be enough, so I have to increase it to, let's say 395 or 400 kg of cement. So now we cover the minimum amount of water, which is 149, now it's 152. So I would like to share to you also that actually you can use as low as 130 kg of water or 135. Normally I am playing on this water. The reason behind this is that during summer and you have to add ice, so you need some more margin for the ice quantity, and that's why I prefer 130 kg of water, the lowest possible, or 135. So far this is working for me, so I'm trying to suggest to you. And another thing is that when you have high moisture of aggregates, so after the correction of the moisture, you will have very less water, so it will be difficult for the plant, or maybe sometimes the machine will halt, it will not mix because of deficiency in the water content. So let's say we just have to follow this standard. This is just to present to you, but I'm just telling you that in real situation you can go as low as 130 to 135. So moving on to the volume of dry rotted coarse aggregate, ACI suggests 0.72. Let's say I will use the lower figure, like I'll go ahead and choose 0.65 or 0.67, since I need to make it pumpable at 150 plus or minus 25. Next, our air content or entrapped air content for the normal air and non-air entrant concrete. ACI suggests 1.5% of air content, so you can copy this assumption or as provided by ACI, or maybe you can opt also 2% depending on the entrapped air that you are having during the actual production. So you may opt to use the 1.5, or if it's really 2% for you, then you can always write 2% here. So moving on, the finest modulus for the fine aggregate is automatically being calculated, of course, based on the combination of the two fine aggregates. I have here natural sand and crushed sand, so I predetermined that the combination is 70 to 30, and you can always check it here. The fine aggregates are in the limit, and for the coarse aggregate, we can also check it within the limit as well, and predetermined to be 59% for 19 mm and 41% for the 9.5 mm aggregate size. And for our dry rotted bulk density, this is actually a combined dry bulk density. So it is after combining 59% and 41% of the 19 mm and 9.5 mm, we get 1,726 kg per cubic meter. Next will be the mass of coarse aggregate. So simply we will multiply the dry rotted bulk density to the volume of dry rotted coarse aggregate, 0.67. So we get the mass of coarse aggregate to be 1,156 kg per cubic meter. And next is the solid volume of material except for the fine aggregate, of course. So this one is simply dissemination of all this material from cement, admixture, cementitious material, coarse aggregate, as well as the void air content or the air voids in volume. So summation of that will be our solid volume of material. And to calculate for the solid volume of fine aggregate is very easy. Simply 1 cubic meter minus 0.69. So therefore we have 0.31 solid volume of fine aggregates. And for the fine aggregates, knowing that we have two fine aggregates here, so the volume will be calculated based on the percentage that I use. Let's say 70% of natural sand. So 70% of 0.31 provides us 0.21 volume. And for the crushed sand, it's 30% of 0.31. So we have here volume of crushed sand to be 0.09. Okay, moving on to this second or section number 2, which is the ingredient details and batch weights. So we have here the OPC 400 kg, the water, wherein we consider the water content of the admixture. So we have to deduct it. So from originally 152, it became 147.5. Admixture, I assume 6 kg. So we have here SSD weights based on the SSD condition of aggregates, and I have also here dry batch weight based on the dry condition of the aggregates. Now for the calculation of the absolute volume of the material, so this is the typical formula. For example, the mass of the OPC 400 divided by specific gravity divided by 1000. So everything is the same in the equation. And the same for the coarse aggregate as well. So for the mass of dry aggregates, let's check the coarse aggregate. So I have here 59% of the predetermined mass of coarse aggregate. So 59% of 1156 is 682, and 41% of 1156 is of course 474. And for the fine aggregate, simply we will multiply the volume by specific gravity multiply by 1000. Same goes here. And this is our first density. You can check it by actual density test. So it's just a summation of the SSD weights of this material. We have the volume. You can double check it here. So we have 1 cubic meter. We also have here aggregate to cement ratio. Aggregate to cement ratio or cementitious ratio. This will give you an indication, like at this time 1:5. So normally the concrete is in this range. And so now moving on to the aggregates grading and combination. As you can see that these aggregates are combined. I have here 5 aggregates, 1, 2, 3, 4, and I will combine it. So using the template, it will be much easier to understand how it goes. So this is very simple. You get this template, and I put the link below if you want to download or avail this template. So next, the same thing happens here. Combine aggregates for the fine aggregate. So let's just show you how it performed. If I change this to different combination, then you will see that it also changed here. And let's go back to the previous one, which is 59 to 41. It changed a little bit here. For the fine, let's for the sake of this presentation, let's say I'm using 0 here and 100 here. Still on the range, but very high. So let us just go back to the previous combination, which is the 70-30, wherein we are more comfortable to look at this chart, since the combined grading for the fine is within the, or almost in the middle of the upper limit and the lower limit. So let us look also at the other criteria for the placement method. Let's say 125 diameter for the pipeline of the pump. So we are still in the limit between 52 to 55% of the mortar volume. And one more thing, the paste plus air over the aggregate voids is very good, because 123%. Normally I'm using 125% for the pumpable mixture. Pumpable, like 220 slump maximum. So the pumpability graph also is okay. We are above this target line. As reference to the ACI 304.2R, we have to be above this target line, the red line. So our combined percent passing for the aggregates, for the all aggregates, I mean to say I'm using now 1, 2, 3, 4 aggregates, but I can in this template can cater 5 total aggregate size. So I'm just trying to provide you with the best template, so that it will be very functional. Even if you go to the Middle East, you will find that we even reach to 5 aggregate sizes. So this template is very functional. I hope you get the idea or the value of this template. So let us try one more thing. Let's make this 100 mm diameter. So now we are less than the minimum requirement. The mortar volume is only 54%. So in this case, what we have to do is just to reduce the volume of coarse aggregate, and I'll be using the lowest possible, or the lowest limit, 0.65, and sure enough we meet the minimum requirement again. So very simple. So let's try another thing. Let's say I'll be using this mix station for, let's say, paving machine. So now the criteria is different, and I will be using the coarseness and workability factor. The idea is to put this red dot within this, or inside the box, and most likely in the middle of this box. So let me try to do that by increasing the volume of coarse aggregate, as referred to the ACI recommendation, which I really appreciate also. 0.79, and let's review again. So sure enough, we are in the box. We are inside this box. So the mortar volume is within the limit, minimum 48%. The coarseness factor is 55%, so within the limit. Workability factor is 28 to 44%. We are getting 35%. For the fines, no issue. I can simply adjust this one, 20%. We need 24% minimum, so I have to make this 100%. It's that simple. So let us make this 0, and let's look at the parameters again. Sure enough, we meet the requirement. So simple. The coarse sand is 16, minimum is 15, so almost everything is met. For the coarse aggregate, let us see, still we are on the limit. So I hope you see the value of this template. I hope you get the idea how flexible this is. It will really help you in your career. And if you like this template, if you think it will help you or it will be useful for you in long term, so I put the link below. Click the link and avail this template as you like. So that's it. Thank you for watching. Thank you for your time, and I hope you find value on this short presentation. I hope you can apply these tips and techniques to your own mix design template in your own way. And see you again in the next video, where I will be presenting the concrete mix design optimizer, where you can automate the way to find the average compressive strength at 28 days using this wonderful chart. It will be perfect for you. So see you in the next video, and thank you again.